this computer, and then I'll share my screen of the, yeah, I guess I'll do the first problem, or well, I guess, yeah. And so, are you all ready?
One second, let me read the instructions again before you go. All the questions below, create a chart similar to show the group, identify the unit. Let me take a screenshot of that and put it on the document
Okay, yeah.
so that we have a reference for the diagram.
I think I can just copy and paste all this.
Would it copy the,
That's good, man.
Oh,
I don't know if it copies the picture, that's why I was going to take a screenshot.
oh, okay.
Do you want to leave your text and I make the picture just the code or like
Sure.
that little table? Okay.
Yeah.
How do you crop this? Oh, there it is. All right, that should be enough. I'm sure we won't have much trouble. There's 6 questions, so we have to do 6 of these.
Ew. Okay.
Yeah. And then yeah. So I guess we'll make an example table. So we'll have our,
It might be easier to do it on paper because in the instructions, they're like, just do it on a paper and take a picture of it to submit. But
okay.
if you guys want to type it out, that's cool too. I think that way we can collaborate easier, like we can
Yeah.
talk about it. But
You could, I guess, make a table in there or like Google Sheet and then paste it in that doc, and then you can edit it from there. Or however.
You could actually just make a large table like this.
Oh, I just don't like how like Sheets and Microsoft Word do their tables because Excel's far better at it because that's what it does best.
Yeah, but we can like format it like this. And total doesn't even be that large. Cost and the code are going to be the biggest sections.
I think you only really have to worry about code and then because most of cost is pretty small, right? And the only reason their cost is so big is for that one and
Yeah,
that
but-
one that's the biggest, they added a lot of spaces where they didn't need to.
Okay.
Yeah,
Should this be good then?
I think so. I mean, I guess we can always change it if we need it.
Yeah. Well,
And I can also like write it down as we do it, just in case we want to use the picture instead, if the table gets too big or something.
yeah, sounds good. So do you want me to take the quiz now?
I'm ready if y'all are.
Go for it.
Just recording, right? On your screen?
It does say recording on the top left.
Okay. Yeah, I'll press start.
Okay. Determine the code
Here,
complexity of the code below.
Here, I'll put it in the table.
Yeah.
We can actually merge a bunch of this.
Would you want to do that? Because I think we want to find the cost for each line, right?
Yeah.
Wouldn't it be better just to have it in the rows? I don't know. It's whatever.
Well, code could be merged, but everything else would be like separate.
Okay.
You treat it as one iteration.
I think if you copy like the number of lines it has, it will copy it into the rows appropriately.
Oh well. I'll just
Okay.
everything.
Sorry.
Yeah.
So that's a nested loop of sum. There was actually an example of that they gave us already in the notes. Let me pull it up.
Yeah, this is going to be, what is it?
Pretty sure it's just n squared, right?
Yeah, because it's 2 loops.
Yeah.
But yeah, we also need to do the cost. So for the first one, this is just 1, right?
Isn't it 0 for assigning stuff?
Is cost like sum? Is that what that means for this one?
Yeah, but in the table they showed, the assigning was 1 cost.
Oh.
Well, it was 1 after the first like iteration, I think. Oh, wait, I'm actually looking at it now. It looks a little different.
Yeah, because
So I guess the first line is if the code never ran in the first place, so it shouldn't have anything but dashes in it. And then the second line is back to when you start running the code.
Wait, so should this be 0 then?
They had a dash for both of them. Like because
Yeah.
the code never ran, nothing's been initialized. So the first row is like dashes, and then
Okay.
it'd be like a number of times 1, and then 2, and then 3, and so on and so forth.
If you go
Oh, why
to
aren't these all?
Oh,
Here
center.
we go.
if you go to page 3 on the code complexity notes, declarations are a 0, assignments are a 1. The example that they have, the second example that they have there.
Wait, where on page 3?
Page 3 in code time complexity notes.
Oh, I'm in the wrong note.
I can paste the link.
Is it not the asymptotic analysis one?
No, there's another one
Do you mean like the slides?
here. I'm just pasting it in the chat.
Okay, thank you. Because I'm lost. All right.
That should work. Yeah.
So what exactly was on page 3?
On page 3 in the second example, for the declaration, on line 2, when they're doing int counter equals 1, it says 0 plus 1. 0 is for the declaration, so declaring int counter is the 0, but assigning
Yeah.
a number to that is
1.
a 1, a cost of 1.
Okay.
So you were actually right the whole time that sum equals 0 should be cost of 1.
Okay.
Okay.
I think. But the number of times it runs is probably.
Yeah, 1. And then
Yeah.
the total is 1. And
Oh,
then
so it doesn't matter what the value is, just as long as it's infinite value.
Yeah.
Okay.
And so there's 1 for the equals. And then we're going to add 1 for the
Less than.
less
It's isn't it n plus 1?
Oh, well, the way they did it in the table is over here, where they didn't have
Oh,
any of the n. They used the n for the number of times.
got it. Makes sense.
Yeah.
But
And then for the I++, that's going to be, we count it as 1. That it said so in the notes, if I remember correctly.
yeah.
Yeah. And so the number of times, this is only going to be called once, the equals. Then this is going to run n times. And then it's going to happen twice because we have to increment and then we're checking if it's less than. So it's n or 2 times n. And then that'll just be 1 plus 2n, I think.
Oh, wait, why is there not a plus 1? Why
Plus
is it
1.
not like 2 times n plus 1 in that number?
So this is less than n. Over here, they
Okay.
have less than or equal to n. Oh, wait.
Oh,
No,
so it
never
has
mind.
to.
No, never mind. They start at 1. Okay, so I guess we have to do the 2n plus 1. And then this would be 2n plus 3. Yeah, because I'm looking at the table. They
Mhm.
go from, yeah.
Yeah, I think the same would apply to the nested loop though, thankfully.
Yeah.
Like the same for the loop itself, it would be the same, but the operation inside would be n squared, right?
Yeah, because we're running this n squared times because each of these for loops are going to call a set of these for loops. Or yeah. And then plus plus plus. Number of times. That's going to be called n times on the left. Or is it n plus 1? And then I guess we can worry about that later. But then
It is n plus 1, I think.
yeah, okay. So I'll put parentheses around it. Just make it look nicer. Then we're gonna run the right side twice, but this time it's gonna be n plus 1 times for this, but then it's also running this for loop n plus 1. So it's n plus 1 squared. And then we can superscript There we go.
I think the short was control plus. or-
Oh,
yeah.
yeah. That sounds about right. That's 2n control plus squared. Oh, that did not work.
Did I read it wrong?
Or, I mean, I was trying to, or I'm not sure if it works inside the table. Yeah, it's control dot.
Oh, my bad.
Yeah,
Makes it
2n
work.
squared plus 2. This will become 2n because n times 1 times n. So that's 2n. That becomes 4n. They're adding another n. That's 5n. And then this is 1. And this is 2 times 1. So that's plus 3, right?
I'm writing it out just to double check,
Okay.
but I think you're right. And then all of that is times 2, and so it's 2n squared plus 4n plus 1. And then you also had the n plus 1, so 2n squared plus 5n plus 2.
Or,
Where's the last 3 coming from?
the 2 times the 1 in the squared.
Oh, yes,
Plus
that, yeah, I missed that one. Yep, you're right. Yeah, the math checks out.
And then this is still 1. And then we call it 1 time. And we have 1. And then we have our, what did they say? Final. And then the final will be 2n squared control dot plus 5n or plus 7n because we have the 2n and the 5n. Then 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 1 is 8. And then when we take the big O, this will become O
N squared.
n squared. Yep. Did not work out well.
Let me, I'm gonna go ahead
Oh
and
wait,
delete
can I
those
copy?
zeros.
Oh wait,
Oh, sorry.
Yeah.
I was gonna
Go
copy the
ahead.
table.
So
Yeah, because
I'm
like I
assuming
think the
that
code is
n
gonna get
inside the
longer.
parentheses is like greatest power of n that's been a thing. Like we had an n cubed to be a n cubed. I'm relearning this and going to the slides. So
Oh yeah, from last semester.
yeah, I haven't done any computer science courses in like a year, so we're calling a lot.
Yeah, I think they required us to do big O and 222. So yeah, here's problem 2. So yeah, I guess I'll stop sharing, but I'll put the code in the table.
Okay.
Someone else needs to do the next problem.
I can do it, but I think I need some help typing it out.
Yeah.
Okay, I can help with that.
Okay, can you guys see my screen? Oh,
Mhm.
okay, let me just wait for you to put it in the,
Here, I'm gonna put the raw code before the table, so just we can check.
yeah, just give me 1 second. The Zoom controls are getting in the way, so I gotta. Okay. This looks like the same code.
It's a little different.
Yeah, there's a
Okay.
plus equals 2 instead
Yeah.
of
Okay,
This is,
I just wanted to
first
make
part
sure.
is pretty much the same.
Okay, so the first line and the last line are the same, so I'm just gonna leave those as it is.
Mhm.
So we just need to mess with the loops. And for those two, this one is the same. This one is the same, so I don't need to mess with that. This is also the same. It's only this that's different.
yeah, the plus equals 2.
Yeah,
where's-
I think with the plus equal to, there's like a specific,
yeah, they mentioned that it had to be, it's worth 2 now, because some computers do the plus plus as one operation,
right?
right?
Oh, so they have to do this operation twice.
Yeah, like the plus equals becomes a plus and an equals.
Oh, so it's just plus.
So is it just that? I just changed this to a 2 from a 1, and then I changed the n+1 inside to an n+2.
Yeah, that sounds about right.
Okay, so then this would be n+4. And then this equation will change because
Yeah, we're running it n plus 2
this,
times.
yeah, this would be that instead. So let me just write out the math for that. It's
So it should be the same except that last 3, right? Oh, wait, no, I think that the middle changes too.
times 2, so 2n squared plus 4, 8n plus 8, and then I gotta do n+1 on that, so 2n squared plus 9n plus 9 is what I got.
Um,
It was control dot for the,
control dot for the exponent.
I don't think it's the same on the Mac.
Yeah,
My
Mac is
bad.
working.
Format
So-
text. Format.
Format text strike or superscript is command dot. Okay, I should have tried
There you
that.
go.
So I got Jacob, did you get the same answer? I don't know if somebody else was doing the math too.
Yeah, so it's gonna be 2n squared, and then you're gonna have the 5n, right? Or 9n, yeah, 9n.
9n.
Yeah, and then you're gonna have that's gonna be 4, 8, and plus 9, right?
Yes, plus 9.
Yeah, that looks right.
Okay, and then the n math will also be a little different because it would be, this would be n, and then is it just 9?
It should be 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 1 is 15. And then the 9n will become 11n because you have a
Because
2.
you're adding the, yeah. Okay, but the biggest one is still the n squared, so that one's just the same.
Mhm.
I can just do another one while I'm here, and then we can deal with.
I guess I'll take, there's 3, there's 6 total problems.
I'm
Yeah.
going to move the total column a bit to the left.
Wait, do we, Jacob, is it just 4 more of these types of questions, or is this just
Yeah.
a part in the first question?
I mean, it's all the same.
Okay, got it.
Well, question 3, well, question 5 and question 6 get a lot longer,
Okay,
but yeah, question 3 is like relatively the same size.
well, I don't want to take maybe 2 easy ones in a row, or like, I don't know if I should be taking 2 easy ones, then I'll just stop sharing and then I can come back later.
Okay.
Okay.
It feels
Um,
unfair for me to do 2 easy ones.
Um, I guess I could share this part.
Yeah, I'll put the code down for problem 3. And then, yeah,
Okay, so first and
yeah, I'm gonna put the
Third
code back for
column.
problem 2.
Sounds good. I deleted it for some reason, my bad.
or first and last one. I treat times equals 2 like plus equals 2, like where it's 2 multiplication iterations.
Oh yeah,
That's
times
just
equals
something.
2. I think that was log, right, in the notes.
Yeah,
They
Let me
say.
do those notes.
I'm gonna check, but I'm pretty sure you're right.
Yeah, because it cuts it in half
Yeah, so for
each time.
come in here.
multiply equal to, it's a log base of 2n for the loop. It's on page 5 at the end in the code time complexity notes.
Let me go to that.
It's highlighted in green.
Oh, okay. Thank you. Log 2n.
Subscript is format text. It's a comma for the shortcut. It's control comma.
Oh, okay. Is that it? Yeah. Okay. So, oh, I guess it's just change anything. Oh, I get log 2 to the power of 2. Oh, wait. All right, I guess that formatting doesn't work. I think that's right for that total.
1 plus 2 log base 2 of n. Wait, did you need to
Because there's
square
a
it?
two out front, I'm pretty sure that this here.
Yeah, if we move the 2 inside, we can do that. Because the log rules, if it's constant in front of the log, you can make it an exponent inside of the log.
Okay, so this is right.
Yeah. Do we need a +1 or -1 for the log 2 of n though? Like how we did with the n+1? Or because I didn't like count.
That's a good question. I don't think we do. I think we just have it as is. Oh, I have to change this too. And this is still 2 out here. So in this middle one, you said that it cuts the runtime in half when I do the times 2 or times equals. Okay, so that carries over into this next line right here, this X4 loop.
Is there like an extra subscript there at the bottom?
There, yeah, that I don't know where that came from.
Yeah.
Oh, that came from where I looked like I wrote it. So then,
Oh, the math on this one is easier because it's just n+1 on what we have above. So it would just be 2 plus log base 2 n squared plus n, right? Or does
yeah.
n get cubed? No, n doesn't get cubed. It's just
No,
a
n just-
simple addition.
Yeah.
So n plus 1 plus log.
It's a comma.
Oh,
I thought you were trying to remember what it was.
I was trying to do it before I made the 2 and then realized I couldn't do that. So,
You're on the next line.
oh hell.
I think you just have to click control comma again for it to go back to regular cursor.
Okay, thank you.
That's control dot.
A lot doesn't work on mine. I don't have a Mac, but it just doesn't work. So,
Okay. Also, I think it needs to be n+2, right? Because we have the 1 plus from the statement above. Or am I wrong?
So I think this just runs because this goes from n or 2 to the, or well, it goes from 2 to the 0th power to less than 2, or well, I don't know. The issue is I don't know like how many times this is gonna run. So if like n is 3, we're gonna check, we're gonna run it, or if n is like let's say 9, we're gonna check it when I is 1, when I is 2, I is 4, I is 8, and I is 16. And so log 2 of 9, that's around log 2 of 8, which would be 3, but we ended up running it 5 times, right? Or the check.
right.
Here, we can check it like with the first problem. So we know that n plus 1 is equal to, or well, in the first problem. So we have, yeah, I went all the way to the first, but
Okay.
we have, let's say n is equal to 4. So we're going to check when I is 0, I is 1, I is 2, I is 3, I is 4. And so that's 5 times. So that gives us the n plus 1.
Right.
And then if we go to the same thing on problem 3, then we say like n is like 9. And then we say I is 1, I is 2, I is 3. Well, not that. It's incrementing by 2, sorry. I is 9, or I is 8. Then I is 16 is when it stops. Right?
Right. So
Yeah.
like the n divided by 2 plus 1.
Yeah, or well,
He also wrote it under problem 3, by the way, just letting you know.
Yeah, I'm at under problem 3.
so yeah, this is around log 2 of 8, which is equal to 3, but then we ran it 2 extra times, so isn't it log 2 of n, or log base 2 of n plus 2?
That sounds right.
Yeah, because if we take like, for example, or well,
Like this. With log base 2 of n
actually, I think it
plus
should just be +1, right? I don't know.
2. Let me.
Honestly, it doesn't really matter because at the end of the day, it's just going to be n. The O notation is just going to be n squared. So, like, we wouldn't care about this, would we?
I mean, unless they're checking to make sure everything inside works or looks good. What are you saying? It's log base 2 of n plus 2. Or plus 1. I think the plus 2 sounds about right. I'll move this over. Oh, then that changes a lot. Okay. Plus 5. And then oh, they just changes it to 5.
Okay, so yeah, we're doing +2.
And then 1. $12 plus.
Is it going to be? Never mind.
The one on the left, where it's n plus 1 for the third row. Is it going to be n plus 1?
Which
Because,
are we looking at? The
oh
row?
wait, it doesn't depend on it, right?
I don't think it does.
Yeah, but then we're running it log 2n times, right? So we'd have to multiply it by that. Or,
Oh wait, I'll need to redo this. Okay.
yeah, so number of times gets pretty long.
1 times 2. That's a square. I thought I did it and this was right. Are you talking about at the bottom?
At the n plus 1, aren't we running it log 2n times plus 2 as well? Because this just counts for this loop, but we're also running this loop outside, right?
Oh, you mean multiply this, run
Yeah.
this amount of times.
Yeah, because that's how many times we're running it.
Need this.
Yeah.
Right. Gross more look at it. Okay. So then why is it back to subscript?
Do control.
Yeah. Okay, and log 2. Yes, I can figure this out.
Oh yeah, and then I think we need to multiply this by n plus 1 because we're running this inner loop as well, n plus 1 times, right? So each of these operations are going to be n plus 1. Yeah.
I'm gonna write this on paper.
Yeah, that's a big.
Yeah, I have to get a piece of paper. as well.
Do you guys just want to write this one out on paper rather than type it out for the final
I
answer?
at least want to do the arithmetic on paper. I can like type it out while we're doing problem 4. I don't care about that, but and log squared n.
Yeah, let me grab the paper.
Can I have n as an exponent?
N is a
Sorry, it's enough
what?
constant.
Wait, N is a
So I
what?
can like n as an exponent since it's technically a constant. So it'd be like log 2 n to the n.
Yeah, I guess you could do that. Or well,
To the n. Plus 2n.
Yeah.
Log squared n
N plus 1
plus 2.
times log N log 2 plus 1 plus 2 times N plus 1 times log 2n plus 1. Oh, wait, no. The first one is just, it runs once, but then we call it log 2n times plus 2. Because this only runs once in the loop. Sorry about that. Yeah, it's like this. Yeah, so I messed up.
Oh, okay. So then,
That
okay,
makes
well,
it
that
a
makes
bit.
computation easier.
It's just 2n log 2n
Plus
plus 2n plus 2 log 2n plus 2. And then we're going to add the other log 2n plus 1. And so that would just be total 2n log 2n plus 2 log 2n plus
4n plus 4 is what I got.
4. Ooh. Where'd you get the 4n?
I got 2n, like log 2n squared plus log 2n plus 2n plus 4. Is what I got.
I might have did the math wrong.
Where'd you get the 4n? So I know there's the 2n that comes from the right side, comes from over here.
I got the 4n from 2n times 2.
Where?
So on the parts that are highlighted right now,
Oh, okay. I see how you did that.
on the part that's highlighted,
It's plus 2. Oops. Yeah, I'm sorry about that.
so I didn't do the math part. That's good to know.
So then log 2n plus 4n log 2n plus
Oh,
2 plus log n squared plus log n. Wait, where's the square coming from?
yeah, so it should be, I don't think you need the bring it inside of the log, because for like big O notation, it's easier if it's like outside the log, so we can just like dump the constant. Like when we do the big O notation at the very end.
Mm-hmm.
So yeah. So if you take the 2n out of the exponent, it just becomes 2n log base 2 of n plus 2 log base 2 of n plus 4n plus 4, right?
How did I get 5 then?
Yeah, I did get the same. Can you say the first part of that again? Like
So
the
it's
n
2
log base 2n.
It's 2
part?
times n times the log base 2 of n.
Mm-hmm. Good there.
Yeah. And then we add 2 times the log base 2 of n.
Still good.
And then we add 4n.
Mm-hmm.
And then we add 4.
Okay. Well, what happened to the first part of that where we
Hmm.
have log base 2n plus 2?
Hmm?
Did you talk about? Let me highlight it. in
Is
the
this
top.
what we got? Move this over.
Yeah, that, or I got a +4 at the end because, or wait,
Oh, I didn't add the two. twos
oh,
together.
wait,
I had 5 different values and about 4.
yeah,
Okay.
2 times 2, that should be 4, so it should be +6 at the end. Yeah.
6.
Yeah, because the first log n 2n plus 2 is going to have, that's going to be 2. And then the second part or set of parentheses is going to have a 4 because there's 2 times 1 times 2. Here, let me highlight it. So we have the first
Okay.
2 over here. So that's 2. Then you have 2 times 1 times 2, which is 4. So 4 plus 2 is 6.
Oh, gotcha. Okay, I missed multiplying it by something. It's valid.
Wait, were you confused about this?
I
No,
was.
I got you.
Or
Oh, okay, never mind. I think we're good.
okay.
Yeah, I
I'm-
just
I'm-
missed this.
I'm gonna change this 2 at the front to like 2 over here. That way we can just get rid of it later.
All right, let me
Big
just
O.
copy this and I'll just edit coefficients we get here. So then we have
We have 3 more questions to do. But you guys said the last 2 are really hard, so
Yeah, we
Good
have about an
stuff.
hour left, I think.
let's just speed through this
So
next, the
13.
last one that's easy, and then we can.
okay.
Oh, right. Oh,
Two,
I
so
think
should be
this is
4.
inside the loop, right? So it actually runs, what is it? The n plus 1 times the log 2n plus 1 times, because it's inside the loop.
Yes.
Okay. Yeah. And so that's gonna be, yeah, that's gonna be n log n
Let
or
me just
n
copy paste here
log
and edit.
2n plus log 2n plus 2n plus 2. So it's, yeah,
You know,
it's n log 2.
this problem is a lot more complicated than it initially looked like with just the change in the
Okay,
multiplication.
so this is what we're getting for the final answer. All right.
Yeah, so there should be a 3 for the total, I think right here,
Yeah.
because we had these two. And then for the log 2n, so it's 2 over here, 2 over here, then 1 over here. So it should be 5.
And then
And for the n by itself, that's 4n
6.
plus 2n, so that's 6n. And then
We have
1,
another 2, so like 15, I think.
1 plus 5,
I think it's
6,
just 14.
12, plus 2 is 14, yeah.
Okay.
And then the biggest one is just the n log n. So we can put that in there. I think we dropped the base 2, right? When we write big O for logs.
Yeah, I think in the grand scheme of things, the coefficients don't really matter. Like it gets exponentially bigger with this value than it does with this coefficient.
Yeah.
I think we drop them.
So we can get rid of the base 2 on the big O.
Oh, do we need that? No, we need that.
I can check his notes to see if that's how he does it.
Yeah, if you look at the slides attached, they reduce, or well, if you look at number 7 on page 18 in the code time complexity notes, it just gets reduced to log n.
Did you say number 17?
Or number 7 on page 18,
Yeah, I see it. Yeah.
it gets reduced to log n.
Yeah.
Okay.
Nice. That,
Okay.
yeah, that was long. I was surprised it took that long. Just the
Yeah, and then we'll
Okay.
total. So it's all in one line. There we go. That's problem 3. Then if you want to, I'll get problem 4 up.
Okay.
Where's problem 2?
Yeah, since I'm here, I can just go ahead and keep it up, and then I'll stop sharing after problem 4.
I mean, honestly, since we're all using the Google Doc, I don't think it matters who's sharing their screen.
I mean, I guess that's true. That's true.
Unless we like decide to write on paper later, which we might have to based on how much writing it is. If typing will take too long.
Computational stuff, yeah.
It's a triple nested loop, and there's a multiplication in there, but it's not the iterator isn't multiplied, so it shouldn't be that
Not
bad.
this.
Okay, so well, the first one is still just a one all across the board. The second one we can pull from our first or second problem because that one's, or actually the first one,
Yeah, because we have it
Yeah.
here.
yeah. We need to change the we need to change a law for the second line though, I think.
Yeah.
Let me find I times I, because I know they did that in specific example, but I think it's just
Oh,
n,
do we
right?
not already have that example?
I don't think we
Okay.
wrote it.
I think it's just n. Well, it's also a little confusing because I don't think in any of his examples he's given us one where something is multiplied by itself in the loop itself.
Was it not in that problem or that table like 4 whatever, except that I times I times I? I saw somewhere he had that.
I think it's all text, so we could actually just look it up. Like if you control F, it should
Oh, it's
come up.
not in the for loop. Sorry, no. That's equal. Okay.
I'll be right back. I gotta wear a sweatshirt. It's getting cold in here.
Mm-hmm. Where's the items line?
Oh yeah, I'm gonna copy and paste from the other table. So
Okay.
yeah, so this is just the first part of the first problem. So we can just do this. And this is kind of similar, but number of times is different.
I mean, unless he wants us to like manually compute how long it's going to take to do I times I. Like
Well,
we can't. But we can't manually compute.
Should I be doing something right now? I missed something. Are you guys?
No, I'm still looking for the I times I, but I'm sitting here like, do you want us to just manually figure out how long that's gonna run?
Okay.
yeah, but I'm pretty sure for this big O, it's gonna be n to the n, or I guess, yeah, because eventually once you put n for I, or it reaches n for I, the big O is just gonna be n to the n.
We'll have that as a playful. He'll eventually give us an index, so maybe this is it. But
I found the I times I think. Oh, actually, no, it's not in the loop.
yeah, that's the one on like page 4. I'm just sitting here like, I think he wants us to sit out and do it. I don't want to, but
Yeah. So you just want to write, what is it? Wait, how did he do it for the,
Yeah, so the way he didn't give us the answer for that, but I think we can just write, wouldn't it be the same as what's on page 5? Wouldn't it be the same as that? Wouldn't it just be log base 2n? Because we're literally just multiplying it by I, right?
yeah, but that's for the count for page 5. That's the count. Like the increment is by that, but the if the the comparison condition is different.
Oh,
So I think it has to be exponent, right?
mhm.
Let me check the slides. He also gave us examples and slides. See if there's something before we go ahead. I can just put the link for that too. Well, we did the previous question right, at least looks like, based on the slides.
Okay, that's good.
Yeah. Yeah, it doesn't look like there's really an example that does something like that. Yeah.
I think we can just put like, well, so if you think about like in big O notation for like the loop, you know that, yeah, so at the very bottom, it should be O n to the n. So I guess these are gonna run, yeah, n to the n times, right? Or well, the issue is that this changes.
I think,
But yeah, since we have an O n to the n, we should probably have an O n to the, some kind of n to the n inside of here. Right?
I think you're right. Also, on the example that they gave us, there's the one that the closest thing we have is k less than j on slide 17. If you guys have this presentation open,
Yeah.
that one gives n cubed, right? Or is that the n squared one? I might be
We're
confused,
looking on
guys.
page 17.
Yeah.
Wait, which number?
So this is a log. So we can actually substitute. Yeah, they're substituting j for n. I
Oh,
think.
wait, you guys are looking at something else. My bad. I'm looking at the slides that I gave the link for in the chat.
Yeah, they're substituting j for n. Yeah, I think we should just put n to the n in here for now, because we know that it's definitely going to run n to the n times.
No, I was just saying, I think you're right, because the only thing we're doing different is we're multiplying the thing by itself, so it would be n to the n as
Yeah.
opposed to, yeah, so.
Yeah, so, and then we're doing it twice because we have to increment as well as compare.
Mhm.
So yeah, we could change this to just n to the n. So yeah, plus 2 n to the n.
Wrong thing. Okay.
And then, so if we add that, that'll just be 4 n to the n plus n plus 1.
What if oh,
Plus 1.
here we go. Okay.
And then for the last one, yeah, the left side will all be the same. I think the right side was where it gets a little confusing because it's dependent on the one above. So I think that,
Yeah,
one
it's going to
second,
run n to the n times, right? Again.
yeah, and I think that one would be the same. That one would be the same as the as PowerPoint one, except it would be for n to the n. So yeah.
Wait, repeat that. Sorry, repeat that.
Oh, I was saying, because we're checking for the one that's above,
Mm-hmm.
the one that's above it, I think it would do it n to the n times 2. Like, so I think it, shit, I don't know how to explain it, because when in the slides, when they're comparing k to j, where k is the latest loop and j is the loop before it, it's n cubed.
Mm-hmm.
So for us, it would be, or sorry, and 10 squared. But for us, it would be the same, except we have it to the n. So it would just be n to the 2n, I think. Jacob, is that right? Or
Actually, I went back to the instructions. So it
Oh,
says
what
use,
happened?
use the example below as a template for your answer, or some classes may use summations. So do you think we could actually use a summation symbol? Because it's not going to be exactly n to the n, right? Because I is changing. And so I could be, so if n is 5, I is going to go through 1, 4, 5, and then, or well, I guess so. I don't know. Yeah, I think for now, just keep it n to the n. You got the general idea. Yeah.
I was talking about the next step. Would it just be n to the 2n times n plus 1?
Yeah,
Or
sounds about right. Yeah, because we should be running this amount of times. So I'll copy it here, make it faster.
do we need the n plus 1 on the third step there?
Yeah. That's what I had originally. I mean, we do have to run this.
Wait, this is running n to the n times, right? Or like,
Yeah, this is NPM. Yeah, I have it. Script is small, but yeah. Okay.
yeah, that should be it.
Oh, okay.
Yeah, because we're running the left one a certain amount of times. And then, oh, oops, sorry.
Oh wait. Oh, so this is just starting. There.
What is it?
No.
It's 3 n to the n. Or wait. I think it should be n to the 2n plus n to the n plus 1, and then plus n to the n, because they're all different exponents.
Yeah, wait, yep. Yeah, I was like, that didn't feel right. Like that.
Yeah.
Yeah, okay. Right. Then we come down here. Totally so gross.
So we'll have to add all that up.
So 4n to the n, so that would be 5n to the n, right? 5n to the n, and then n to the n plus 1, there's only one of those. So, and then n to the
Two.
2n, there's 2 of n to the 2n's, yeah. And then for n, there's 3 n's, so 3n, and then for the number itself, it's
5.
Yeah.
1, 3, 1. Is it 5? Isn't it 4?
1 plus 3
One.
plus 1.
Yeah.
Oh, that's 5. I'm stupid, my bad.
Yeah. And then if we take the largest one, which is 2n to the 2n, we can get rid of the constants and we're left with n to the n.
Okay.
So yeah.
So we don't have this exponent. We don't have this 2n up here. It's just n.
Wait, what'd you say?
This 2, do we like neglect it? Oh, God.
Oh, sorry about
This
that.
2n. This 2n.
What'd you
Do
say?
we not?
We don't need
the-
the 2's in the big O. Big O's are only
Okay.
the variables.
Okay. Okay.
And then I'm gonna put problem 5. Problem 5.
I can type this one out.
Okay.
Let me pull up the document.
I'm going to put the code down. It looks like a binary search. I think it's a binary search. It looks like a binary search.
Wait, didn't we? Oh, problem 5 is below. Wow, that's big. Okay.
Yeah, this is a binary search, I'm
Let me
pretty
see.
sure.
Ew. Okay.
Yeah, because we actually, in our CSCE 222 class, we ended up doing a binary search. And then we had to do a big O for it.
So do you know what you're doing here already?
I think ours is different because we counted the assignment statements, and then he doesn't want us to count the assignment statements, right?
I think so. I mean, I guess I really can't. I mean, it didn't look like it in his notes.
Okay, yeah. So we just kept the assignment statements. Yeah, I'll put this in the table.
Okay.
I think we need a couple more rows.
Yeah.
Is the last one even longer than this?
I think it's a bit shorter than that. But yeah, it's 2 loops. Question 6 is 2 loops.
Okay.
Or well, it's 2 separate.
That makes me
loops.
more nervous. But
Yeah, actually question 6 looks easier because it's 2 separate loops. Like there's nothing nested. It's just 2
Oh.
loops.
Does he have like how he wants us, like, does the function definition count as anything?
I think it counts as 1 in the table.
Okay, so I should just leave that row as it is. I don't see an example of it. That's why I'm like wondering.
I mean, I'm not really sure either.
Well,
Oh,
okay, so if you look at page 9, it ignores the public line. So maybe,
you don't count it?
yeah, I think you just ignore it.
Okay.
If you look at page 9, it might be, I don't know, just, I would double check that, but it looks like we ignore it. Which makes sense. I mean, we don't, like, I feel like it shouldn't really take time for the computer to read a function. Does that really count as,
Yeah.
mhm.
and then this would all be ones, right?
So we are
int
not
low.
counting.
Yeah, some of these are pretty
Okay.
simple.
Assignments are 1, but declarations are 0. So this int low equals 0 would just become 1. And then
Oh,
int
and-
high equals numbers dot size minus 1. Wouldn't that be 2? Wouldn't that be 2 for everything? Because first it's assigning high, and then it's also accessing something for that.
Yeah, so it's 1 access, 1 subtract, then one assignment. So it's 3.
3, not 2. Okay. Oh, is that a superscript or subscript? I can't tell.
For the comparison, where it's like if something is greater than or
Which one?
less than, is that one?
While low is less than or equal to high. Is that n plus 3.
So, oh, okay. I saw how he did it in the CSCE 2.2. So I guess what we could do is copying those notes. Here, I'm gonna copy from my notes of what it was. So just put X for there for now.
X,
So
no
compare,
N.
yeah, just put X and then we'll define X later. Because I don't
Okay.
think he defined it in his notes. But then since we were sending this as a file, presumably a PDF, we'll make like 6 PDFs.
Oh. Yeah, I see what you're saying. We can just take a picture and then save it as a PDF. Like we can do a screenshot and then save that as a PDF to turn it in, as opposed to having to download each page individually.
Mhm.
Although it might be harder for number 5, because it's a really big table. So for that one, we'll probably have to download it.
Oh, there's only a upload file option.
Yeah, that's what I'm saying. For number 5, we will just download the pages that number 5 is on and then upload it as a PDF whenever we're done with it.
Okay.
But what about this line? Int middle equals low plus high. Does that call on X again? Because it's calling on low and high again.
Which here, let me see. Yeah, sorry, I'm writing below, but yeah, middle. So that's one add, and then we're subtracting, and then we're dividing. So that should be 3 operations again.
Isn't divide
Yeah,
log
but
base
then
2?
it's running X times, remember? 3X.
Yeah,
Because of the while loop.
yeah. But isn't divide usually log base 2, or is that just for when it's in a loop?
Wait,
Because
what's
in his notes,
Hmm?
oh, that's for that. Never mind. That was just for incrementation. We're good. So if comparison number less than numbers.get middle, is this still in the loop? Yeah,
they're
that
all
is
in the
still
loop until they're all in the loop until return false. Return false is the only one not in the loop at the bottom. So everything should be ran X times or
Or
something like that.
Okay.
Yeah, hold up. I'm
Um,
writing the explanation for what we're gonna put.
okay, I'll wait then.
Yeah, but you can continue with like filling in the table with like the X's and whatnot. So it's
Oh,
Else like actually have
yeah, so
like
it's
a
gonna be
count
here.
with the else line, or can I just select it?
would else
I
be
don't
in
even
the?
think they counted.
I'm not even sure. Let me see if it's in his notes.
Yeah, because I imagine it runs like with the function where it's like, oh, the computer reads it's like, okay, well here's this other option that I don't have. It doesn't nearly as long to run it.
He doesn't show else being used in the thing, but I also don't think it would count because
Yeah, it doesn't do anything really.
yeah, because
That's what I figured.
you're already doing all the run like in the if. It's just that if that doesn't work out, then you just do else. So I don't think it counts. Okay, so we really just need to figure out
Shouldn't X be like constant because high only ever it's incremented like once. If that makes
Oh.
sense, because we're always checking to see if low is less than high and high only ever decreases by one. Oh, there is a second.
Yeah, I'm just demonstrating the logic behind it. But yeah, since it's a binary, this is a binary search, so at the very end, we need to have O log n for our big O. And then here, I'll increase the font size for this. I guess I'll increase it even more. Two to the 0. Oh, high, slow. Okay. Okay. Yeah.
So we're trying to find x is what we're doing.
Yeah, I already solved for x at the bottom. So this is the proof we used in our CSCE 222 class.
So let me scroll.
Yeah, but it cuts the list in half. So eventually it should make sense, right? Since it's a binary search.
Yeah.
Yeah. And the final, you just add all this up. So this can be OX is equal to ON.
So this right here is x. X.
Well, how do we write this out though?
Yeah, so we're just gonna add all this up to X and then we'll say O to the X is equal to O and O log N. So that's gonna be X plus 1, or how many X's are there? There's 9X, 10X. Yeah, there shouldn't be any N's in the table. So, yeah, so this should just be 1. And then we're gonna add all the X's in the 1, or so it's X plus X plus X, that's 3X. Or I guess, can someone help me count the X's? So X plus 3X, that's 4X, plus X is 5X. plus
Oh,
another
these are
X,
not final. I just wrote these out.
7X. Oh,
Yeah, I was just writing X and everywhere it would apply. I didn't really, these are not, yeah.
one.
Well, because like, because comparison number runs X times. I know that. I just wrote that down, but I didn't really do that.
Oh wait, is this a recursion? Yeah, this is a recursion. Wait, no.
It doesn't
Oh,
really
numbers
call
dot
on
get
it.
middle. Okay.
Yeah, that's just the class.
Mm-hmm.
And then get middle. Middle is just the same calculation of low, or so it's like 3, I guess.
Well, it's just calling on it. So it's like it already exists. I don't know if that counts as a,
Yeah, but wouldn't it have to follow the same format since it's a list? Yeah, but we have about, okay, yeah.
are we running low on time?
Or we have about 20 minutes, but
Should we move on to the next one and get that done before we come back to this, or?
I think we can just put 3x, or we can put the cost as 3, right?
Mm-hmm.
Because it's going to follow the same format, even if we call this function, because I don't think they set the middle variable of the list, right? Like this is C++. I'm presuming that numbers.get, or well, actually,
Well, middle is assigned.
Mhm.
we already found middle. Sorry.
Yeah,
Okay, so that's just one then.
Okay.
And
and then middle -1 would also be the same way, right? Because high is already set,
yeah.
and we're just, actually, does decrement
this should
count
be-
as,
Yeah, since this is all in the while loop, this should all run like X times, I think, right?
Mm-hmm.
4 through 8. So we compare, oh, wait. Yeah. So the issue is if it's one of the ifs run, then the other else ifs and else's won't run. Yeah.
well, only one of them would run. So
Yeah,
we
one
can
would
just
say-
we can just fill out one of them and leave the other one empty.
Yeah. So do you want to just like leave these blank? Or
That, I mean, it makes sense because only one of them would run. So I think we can just leave them blank.
okay.
As long as except for the else if, right? Unless the else if, because the else if would run if this one doesn't go through, right?
Yeah.
Because it
that
still has
does.
to do the, but it's just a 1, so does it matter?
Yeah, but we're only gonna run one set of these, right? Or this is 2. Yeah, we're only gonna
Well,
run one set of these at a time. So when we add them up, we should,
oh, I see what you're saying. Yeah, you're right. You're right.
yeah. And so I guess it's fine that this is highlighted.
Yeah, I just highlighted them because I wasn't sure if those were right. Yeah, but I think they're good. Also, I already uploaded the screenshots for questions 1 through 4. As
Okay,
long as the Canvas submission box allows JPEGs, we already have those in the drive. So
that's
just download them and upload them to the Canvas whenever we're ready. I will upload a PDF of question 5 right now.
Oh, yeah, we need to do the final though, real quick.
Yeah,
So, add the
I-
X's.
I'm just gonna download this while you guys, while we start on number 5.
So it's gonna be 5x. Or
Oh, you're not done yet.
yeah, because we need to add the X's up. So that's
Yeah.
This returns
2x.
true only once run.
Yeah.
Runs once, right?
So that's the issue because it's gonna do 3 different variations. So I think we can just we're only gonna count one of them. Because if it goes into a certain if, then
You would count the biggest one, like
yeah.
you would count 2x and not x.
Mm-hmm.
So that's gonna be 3x plus what is it? 5x, or this is 3x right here. Then this becomes 6x, 7x, and then plus 3 plus 1. So that's 4. So the biggest case is 7x plus 4. And then
Wouldn't it be 5?
Hmm?
Wouldn't it be 5
5?
plus 5? Because there's 1, 3, 4, and then there's also the return false to 5.
Oh, okay. Yeah. So I guess that would be our biggest case. Yeah, since we
Oh,
care about big O.
interesting.
This is superscripted. So
Yeah, that's what I'm trying to undo.
here, let me see.
I got it.
Okay. Yeah, and then I wrote the explanation of what O to the X, why O to the X is equal to O log N.
Okay.
below. So yeah, we can
Sounds
just,
good.
you can screenshot this whole thing.
Yeah, I'm gonna make this one a PDF because it's over multiple pages.
Yeah.
Um,
And
Let me
then
get
I'll
the page
copy
number.
problem 6.
Yeah, so that's what. 8, 7, 6.
So here's the code.
Question 5 is uploaded.
Okay, that's good.
How much time do we have to finish this?
Like 17 minutes, maybe around
Okay.
15.
Should
So
be
we
able
should-
to.
So we need to finish this in like 10, but the
Yeah.
last one's pretty simple.
Except for this part is a little complicated, but we already have the code for that, thankfully. So we can actually copy that over.
Yeah, so it's just n to the n. But that was in a nested part of the loop, but we can just easily rewrite it.
Yeah, here, I'm gonna. Wait, where is it? I can't find it.
Here, we can just write n to the n. Or well, yeah. This is gonna be 1. And then this is gonna run, what is it? 1 plus 2 times n to the n times, right?
Yeah.
And then 1 plus 2 n to the n,
Where are you getting the 2 before the end to the end?
because we're doing this and this.
Oh, yeah, okay. Sounds good.
And so in here, we are doing this again. Actually, wait. Oh,
I
okay, it
think-
just wants
I think-
complexity of the code. Okay, that's fine. We don't actually have to solve for it.
Oh,
'cause
when
there's
did
a
this be end to the
CSCE.
end?
Yeah, so this would just be n to the n times.
So we don't have to write out the table for this question?
Or no, we solve this like the other questions.
Okay.
Yeah, so this would just run n to the n times, but there's 2 operations. So, right?
I think it would be 2 end to the end. Right?
Yeah,
Because you're calling on sum and then you're iterating sum by j. So it would be 2
Yeah.
end to the end. Yeah, that makes sense.
and so that's 2 n to the n. And then for this isn't part, this is a different loop. So that's gonna be n. No. And this, it's this. And then we're just gonna copy what we did for the first problem. So I'll go up there and copy it.
Let me find the problem where we compared those two. I think it's problem 4, row 5, row 4, problem 4, row 4. So I think it's this, right?
Oh. But that was nested is the issue. I think.
Oh, my bad, my bad.
Yeah, so this is by itself. It's out. The 2 loops are separate, which makes it nice. So yeah, this should be 1 plus, this should be 2n plus 3. And then
The last one's 2 again, right? Because it's
yeah,
just
2. That's 2 times n plus 1. And then that becomes 2n plus 2. And this will all run 1 time. And then we can just add this all up.
so it would be 1. Okay, so 2 n to the n plus 2 n to the n, so that's 4 n to the n, right?
Yeah.
And
have
then
another
plus 4n, yeah.
And all the constants now.
1,
1, 4,
7.
6, 7.
7 is what I got to.
Yeah.
But the O notation would be n to the n.
And then control dot n. And then, yeah, I guess could you just save this?
Yeah, I'm screenshotting this right now. 1 second. It's a little awkward. Okay, there we go. Can you, it's fine. I think it's not a big deal. Actually, can you move your cursor? Because it kind of hides the N.
Oh, oops.
It shows up on the document for me, like as the little
Okay.
pink thing, you know? All right, I'm
I
good
think
now.
that's, is this? Oh, I think that's yours.
Oh, is it just,
Yeah, that's
maybe?
yours.
It's gone now though, so it's fine. Screenshot 5, except, okay, I'll rename that
Yeah.
on
this
Google
is-
Drive, because screenshot 5 is question 6, but it's saved as,
Oh, yeah.
but
downloading
it's, I renamed it.
Yeah. Let me refresh.
Can you share your screen, Jacob?
Yeah, I'm going to share my screen. Share. And then screenshot 6. Download. And then I will go to our quiz. We have about 10 minutes left, so that's fine. For problem 1, it's going to be, yeah. Screenshot 2.
Yeah, I'm also clicking through the Google Drive at the same time to make sure that those are the right questions, and so far it's all been good.
Okay, that's good. Yeah,
Okay,
and then PDF is 5. And then screenshot 6. So does everything look good?
it should look good. Do you want to make sure, like, check through the files locally to make sure that you uploaded the right versions of them? I was going through the Google Drive as you were doing it, and it looked fine.
Okay. Downloads screenshot 1. Yeah, so that's screenshot 1. Here's that's not it. Here's screenshot 2.
Looks good. I don't think I missed anything there. The screenshot.
3. Looks about right.
Mhm.
Screenshot 4. Looks good. Question 5 is this big PDF, which is good.
I think we can submit after looking at 6, but
Yeah. And then if you look at 6,
right. We triple checked. So if there's any issues with their submission, I'm sure they'll just tell us. So I think we're fine.
yeah, okay. And then you saw me, this came directly from the download folder where we just opened it. So do y'all want me to press submit?
Go
Yep.
for it.
Okay. Yeah. I guess who's gonna do the survey?
can do it.
I can. Oh,
Oh,
okay.
either one of us. I'm cool with either.
You can go for it. You can go
Alright.
for it.
I'm gonna stop recording.